Now let's talk about the future of global connectivity in space and also on Earth. And the fourth industrial revolution is bound to connect billions, bound to connect basically anything. If we look at the Internet of Things, for example, promising unprecedented access to knowledge and also to technology. But the big question is, how can satellite communications bridge the still existing gap, especially when it comes to IoT, and unlock the full potential of this new era? And also, what challenges must we overcome to get there? Let's find out with the help of this very, very exciting panel. Please welcome our panelists. Joining us, ladies and gentlemen, is the co-founder and CEO of Stellar, Damien Garot, the Vice President General Manager, EMEA, Media and Network Sales, Intelsat, Rhys Morgan. Also joining us is the founder and CEO, OQ Technology, Omar Qaise. Also from ESA, Nada Alaga. And the Senior Vice President, Future Business and Technology Innovation, SES, Mohammad Marashi. And this will be led and moderated by the CEO of the Luxembourg Space Agency, Marc. Marc, take it away.
Thank you, Chris. And welcome to our speakers. We invited you today around the topic of future of global connectivity. And the reason is, of course, because this is a changing world. We have seen a lot of changes recently. Connectivity is somehow something that appeared more recently, but this is a heritage of something that was called in the early times broadcasting. And as other panels and speakers already mentioned, there are tremendous changes with impacts on industry, impacts on the legacy industry, impacts on the markets, opportunities as well with the new space actors that are coming up. And so today, I think it's good to go through that and see a little bit what the situation is, where is it going, what are the challenges, how does our European players position in this worldwide competition. And so maybe we go first in the first aspect of this conversation is, do you see this sort of disruption in the connectivity markets, in your applications that you, or the users that you serve? Do you see this appetite coming, this need for more connectivity? What are the impacts that you see in your current businesses? Damien, you want to start?
Yes, absolutely. And thanks, Marc, for hosting Stellar on stage. You're right. The world is changing, and that's true also for the mobility and automotive sector. Right now, there are more lines of codes in a car than on a fighter jet. The volume of data that is transferred between a car and the cloud will increase 10 times in the next 5 years. That's about the appetite. But the need is something different. Right now, 40% of the roads in Europe suffer from poor internet. A broadband session will last, what, 3 minutes? And I'm sure that all of us here, we already tried to make a phone call that dropped at the worst time ever, right? What we demonstrated is that, and we demonstrated that to several car manufacturers in the world, is that with SATCOM, with satellite telecommunications, we can bring perfect internet on the road. Satellite is the enabler for this perfect connectivity with one rule, and one rule only. It has to embed itself within the terrestrial solution. We don't have to think from our bubble thinking that space is the only solution. Space is part of the solution for a huge mass market, which is the automotive and mobility sector.
So, Rhys, do you agree with this statement that there is a big appetite?
I couldn't agree more, actually, with what Damien's been saying. So the demand for data, connectivity, and the consumption is growing exponentially year on year. And it's about embedding your technologies and solutions and services within and reinforcing existing networks, and also connecting to existing devices and making that simple, both for our customers, and we're very much a B2B business, and then for our customers, which may well be B2C. And I think one of the things, as a sort of legacy satellite operator, we have very much come to realize is that we have to simplify all of that and also work within standards. And if we can't all work within the same standards, and typically we're following now mobile phone standards, so 5G, etc., then if we can't work within those, then we'll be outside of that, and being outside of that is not a place we want to be. So yeah, I think it's incredibly exciting. It's a lot to do, but it's about thinking about how you deliver that connectivity in a different way.
So you are the ones who are taking new opportunities with the creation of a startup a few years ago, and you are tackling exactly also these appetites from maybe different types of customers than an SES or an Intelsat, but if you can say a word about
indeed, Marc, as you said, so we saw the disruption first with the lowering price on launch cost and also on satellites, nano satellites, and this is what allowed a lot of people like really to start space companies and start offering services. In our case, of course, when we started 8 years ago, it was really to connect machines and devices using a wireless technology, and our choice fell on 5G cellular technology, especially the narrowband part of it for machines and IoT. And then to our surprise, 2022, 5G became a standard over satellite, NTN, the non-terrestrial network. And the direct-to-device now is the biggest keyword, as Rhys say, that in the satellite industry. For first time, we see that the cellular communication is part of the satellite communication. You can connect directly cellular devices or smartphones directly to satellite. And this is part of our technology roadmap and service. And we are actually, we bet on the right horse with the cellular technology over satellite becoming part of a standard. So there are no more silos or proprietary technologies. And this allows today like to roam with mobile operators, just like you're roaming with a normal terrestrial cellular service. And if you look at it, like the prediction for this market is very big. Like GSMA predicts right now probably $30 billion market, but actually they're looking at the like 7% of the population who are in the coverage gap of terrestrial cellular networks. But if you take into account 5.6 billion people who move constantly between urban and non-urban areas and lose coverage, that's actually the biggest market for mobile operators, but also to NTN operators like us, to provide like messaging services and later on voice services to normal mobile users. And this is a great opportunity that we are seeing that is disrupting the satellite industry.
Before we go to Nader, I wanted maybe to also have the view of SES on that, on how this is impacting like Intelsat, a sort of legacy company that is coming also from a different market and now having to adapt to this connectivity need.
Yes, so we've always seen sort of the trend of increasing demand. It's how we address that demand that's sort of been shifting. Where in the past it's been more, space segment only or terrestrial only, we see the coming of the networks. That's really the shift that we're seeing, and we're looking at not operating just in one orbit, but multiple orbits, including terrestrial, as part of that. And that's becoming more and more, moving away from being a provider of just bandwidth to manage services. That shift, looking at all the different ways that we approach it. So we see the trend in how we offer the services and fulfill that demand as a big shift, as opposed to the demand, which the trend for the past 2 decades has been constantly increasing.
Okay, Nader, you are part of the European Space Agency, and of course in the role of the Space Agency is supporting also industry in addressing and these challenges of changing ways of addressing the markets. How are you experiencing that as well as ESA?
Yes. First of all, thank you very much for this invitation, Marc, and good afternoon to all the audience. Indeed, this is a trend that we have been seeing in the past decade or so, And what I can see from the European Space Agency's point of view is the need for change is, of course, is well established. And the way to get there, as mentioned already, looking at it maybe as an integrated system for the end user, where the bit actually arrives or being sent to the end user, is probably non-relevant. It's important to actually have a service with a given quality anywhere to anyone at any time. And for that, the integration of the systems, both from the terrestrial and non-terrestrial, is a key. And to actually activate this, to have a standard or a solution that allows you to actually establish this integrity is quite important. My point been raised regarding the possibility of actually having this 3D systems to be established, and we see this is already happening. From ESA perspective, being able to support the industry in Europe to actually make this happen is quite important to us. And there are quite a number of projects that we are already running together with our member states to actually make this to happen. And of course, there are the opportunities in place, challenges are there as well. Perhaps we're going to talk about it a bit more when it comes to actually delivering the end service, not only one isolated solution. And to us, that end result is what matters.
Okay, and where do you see today the gaps still to be fulfilled?
One thing, of course, when you look at it from there are many items. We can talk about access to the spectrum, which today is not something that is that obvious for somebody who wants to enter to this business. It may not be straightforward, and we see a lot of challenges for startup companies to actually even how to tackle this. Technology is one side, but having access to that spectrum is quite the key. There are a number of initiatives at the international level, at ITU and others, that tackle this, and we are also supporting the industry to be effective in the use of the spectrum. The other side is basically to also understand the economy of scale, what kind of technology has a chance to actually be relevant and to be used in a long term. And for that, of course, the standardization, open standard is an important part. We'll see that will be quite relevant. Of course, looking at the boundary between the new space or non-new space is something that perhaps it comes up. Being agile in delivering is what we see is important. And that's why for many of our missions now, there are different type of classes to being defined. And that would help to also not to put everything at the level of, in terms of the delivery, to have different approaches to actually how to implement the projects. And this is basically for us how to implement and how to help the industry to be able to deliver.
When you talked about the spectrum, I saw 3 heads nodding, so maybe you want to react on that?
I can say something. So, in fact, this is probably the lesson learned for any space startup is first you start thinking about the technology, then you start thinking about the business, you start the company, but then you hit the wall with the regulatory framework, especially spectrum, because in satellite business and especially SATCOM, this is the most important asset. And I think that's something that a lot of people need to learn how to navigate that, tap into the expertise. But at the same time, it's the role of the decision makers or regulators really to realize that now you have a lot of players in the market, you have a lot of innovation. The need to open up that asset for other innovative companies and not just for incumbents is something very key if we want to see innovation to continue and to reap the benefits of such satellite services.
You want to add?
I mean, I think I would just kind of underline that effective management from a regulatory perspective is incredibly important. And the disruption from a technology and business model perspective is real, but also some of the conversations at the regulatory level needs to be perhaps a little bit more effective in certain regards, and that's where terrestrial and, let's say, non-terrestrial operators need to find, in some cases, a better way to coexist, but an easier way of understanding each other and cooperating, and I think that's incredibly important, especially some of the space disruption is going to cause significant terrestrial disruptions too, and so people really need to get together and I think have some more informed dialogue in certain areas about that.
Damien, I wanted maybe shortly to come back on one thing that you said, and I thought that there would maybe some reaction, would be some reaction on that, where you said that on the road today, you only have connectivity on 40% of the roads. So that means that today we have a huge gap in connectivity capabilities, being a terrestrial or satellite, by the way. So how does that impact your business positively, negatively? What would you ask these guys here to do in the future to enable the applications that you are providing?
Yeah. So let's be clear on the stats. 40% of the road are not connected if you use your cell phone today with one cellular operator. That's, in average, what happens. But if we are able to use all cellular operators, but as well as Wi-Fi hotspots when they are readily available, say at the charging station, as well obviously as satellite, then this is a moment when you become having a perfect internet in your car or in your vehicle. And this is where this massive opportunity exists for the space sector. We are then the enabler of this perfect connectivity on the move once we are able to embed ourselves in the terrestrial world, the terrestrial telecom world, where we're going to use cellular by default if it's cheaper or better in throughput, latency, but where satellite can then help for specific application. Could be safety related, for instance. And the applications are huge. They're huge for us, the space sector. We're talking about 80 million new vehicles being built each year. There is 1.4 billion vehicles on Earth today. McKinsey is telling us by 1930, 95% of the new vehicles will be connected one way or another. That's the first consequence. The second consequence is for the automotive and mobility sector itself. With this perfect connectivity, finally, we will see the blossom of this new application for the mobility sector. Safety. Right now, we know that autonomous cars from Waymo in the US, on 3 cities, they have 80% less car accidents than the human-driven cars. That's massive. We will be able to finally enjoy our digital life while we're traveling. And I'm sure that some of you that took the train to come to Luxembourg today know what I'm talking about. Right now, when we travel, we are frustrated to wait from point A to point B. With this proposal for trains, for buses, for cars, to be always connected, then there is a reason to stop using planes. So we can be more sustainable when we move. And the third part, obviously, that the car industry will change because finally, as cars are becoming fully connected, they can be also fully autonomous. We see what's happening in the US and in China today with more and more autonomous vehicles being deployed. We see what's happening also today in Luxembourg with Pony AI, for instance, deploying its activities for making sure that autonomous vehicles are safe, reliable, that just like an elevator where you can have a big red button where you can call for help, they need what? Well, they need connectivity. And this is where the space sector has a huge play, if we are able to do it wisely, integrating ourselves in the terrestrial telecom environment.
So what are you doing today to integrate better with the terrestrial? Because I heard that since 10 years already, and even in ESA, there have been a lot of efforts to bring these or have this convergence between space networks or satellite networks and terrestrial networks. So why are we still talking about integration? Where are we today? What is the gap from that perspective? What do we need to do now to make it happen?
Maybe I can respond to that. So I agree with everything that you said. I think it's the application to provide it on a global basis. But what are the challenges that we face, right? Well, the first thing is that you want to look at the different use cases. And there are certain use cases that the OEMs are willing to continue to use the same technology they're putting on for the terrestrial and use that on the satellite, okay? So for that, for us like an SES we get into the question of, well, that's operating in L-band and S-band, and you need that spectrum. So it goes back to the question of spectrum availability on a global basis to be able to support that, right? Even if you look at direct-to-device, you might depend on the MNOs on a regional basis to create a global, which is challenging in itself. Then when you go on the wideband side or the broadband side, in order to provide a service, and let's say you still need to be 3GPP NTN, and you need a, say, KA terminal. Now you're dependent on the OEMs to actually put that terminal at a very low price, extremely challenging to get to make that happen. So we want it to happen. We've been providing services in commercial aviation, in maritime. Clearly, we would like to be able to support land mobility, specifically, automotive. But these are some of the hurdles that need to be overcome. So it goes back to regulatory issues from a spectrum perspective, also getting the whole ecosystem to work together, which I think is starting to happen. I'm even seeing it on the OEM side, where we can work together to actually implement this technology.
Yeah, I think Mohammad touched on an important point, which is around the terminals, or the antennas, if you like. They will actually sit in the cars. So we made an investment in a company called Kymeta that was fairly pioneering in flat panel antenna development. Now we have a comms on the move solution with them, but that antenna is strapped onto top of cars. In some cases, it may be sort of fitted in a bespoke manner, but we haven't really reached what I would consider to be mass market scale at the moment, both in terms of cost, but also ease of fitting. So the solutions are out there and they exist, but it's actually getting a BMW or a Volvo or other, or maybe even a heavy equipment manufacturer, for example. We have a large trial underway with a sort of agricultural manufacturer at the moment, getting them to adopt the technologies and not just divert and think, well, we'll just put a SIM card into the vehicle because that's the easiest thing to do, and it's very simple for us to do. So it's about challenging that. And often working with the MNOs as well, because they have relationships with these businesses. So getting the MNO to adapt non-terrestrial networking technology, which can be challenging. And coming from a sales perspective, we dedicate an enormous amount of time in working with the MNOs to persuade them that MTN can be a useful overlay, whereas their default is often just to use their own infrastructure and sweat their own assets.
I would like to say about the spectrum, it's true, like in some cases you have to depend on the MNO for their spectrum, but on the other side, you have the MSS, L, and S band, which got standardized for that type of service. But then, which is good news, but the analogy to what you just said about the OEM for the terminal in our world and the cellular is the chip maker, the module maker. And we became like I would say the hostage of the chip maker to release that chip that has these bands and has these services. But the good news is, as you said, it's coming up now. A lot of companies, a lot of chip makers, and a lot of clients realizing the value of LEO NTN. Because today there is a GEO NTN service, yet it's not scaling up because, again, it's the same old style, expensive, monetizing the expensive L-band, limited, and the modules are not completely 3GPP standardized. Like, you will be locked to an operator in the end. And that's why they are coming, MNOs are coming for the LEO market. And to us, to speak to us, like, we really need an open market here, a chip that works with any operator, just like a mobile phone that works with any mobile operator anywhere in Brazil or Australia. It's the same technology, same thing, and this really something we haven't got there yet. It's coming up, but once this is achieved, then we'll see the benefits of service. The same with IoT. Like many years ago, everyone was talking billions of IoT devices. Why it didn't scale up yet to billions? Because the key was to really go into very low price point for the IoT to enable IoT devices and users to use IoT for non-critical applications. We haven't got there yet. Again, it's because of the expensive geospectrum, because of locking the market. And I think LEO, which is going to change that. Yeah.
I might defend ourselves a little bit there. As a geostationary operator, it's not always expensive. You know, we do clearly understand that terminals and service pricing needs to be a level that the market can bear. And I think there's you know, we're proving that there's somewhere where we can play in this, but I would also say your technology and your approach is also incredibly beneficial. I think the two can work together very clearly, but you know, the old days of a sort of locked-in system and you have to be beholden to certain standards and certain equipment, I think those days are in the past, certainly for us anyway. So it's been some time since we've operated an open architecture network.
Yeah, something I wanted to add is that when we created Stellar 3 years ago, we had people coming from the space industry, people coming from the software industry, and people coming from the car industry. And together we created that software that would be in the next generation of cars that would bring a perfect internet on the move, relying obviously on SATCOM, but also on cellular and Wi-Fi. But we didn't want to stop there, because what we realized early on is that the people coming from the car industry, they're very hands-on. They like to see what the product is. They want to have early demonstrations so they can take some bets. And for us, that transformed into putting our software into a box, like an internet router that you plug into the cigarette lighter of the car. We showed that to car manufacturers, and much to our surprise, they said, we want it. We want it not for POCs. And today we have customers from these major car manufacturers that are using this box, where you have several cellular modems, several Wi-Fi modems, as well as satellite antenna that are plugged directly into our box, which is called Global. And they are used today in the US, in Europe, and soon in Africa. That's what we are able to do, opening early on markets with car manufacturers. That is the way the space industry is able to prove things early on. If we only wait for the next release of 3GPP to exist, I will tell you bad news. It will be too late for the car manufacturers. This is today the moment of truth where they're making tough decisions regarding the next telecom architecture. It is important for them to see today what the space sector can enable to them. And that's what we're doing, to answer your question, Marc.
Yeah, okay. It's interesting to see you know, that there is a certain pressure to come with solutions, that, you know, the solutions are different as well. And I wanted to rebound a bit on what Omar said on now LEO solutions, that they can change the game. And we have seen also huge investments in the US with, I would say, radical change also on the market that is threatening, in a certain sense, also existing players. So do you see here LEO as the solution for this global connectivity? What is the positioning of Europe on that? Do you feel comfortable with the current evolutions? Will Europe's operators still be there in 5 years and offering connectivity solutions with what is sort of coming from the US? I'm a bit provocative, but I want to know.
I don't mind having a go. I've already talked a lot, but if nobody else wants to have a go. I mean, I think there's space for everybody, because as you perhaps opened the session, demand is increasing exponentially in many cases. There are many markets that are a long way from maturity. And some of the disruptors, and don't forget, you know, there's a massive Chinese constellation that's on its way as well very soon. These disruptors are increasing interest in non-terrestrial solutions, not decreasing interest. So there are a lot more people today who are interested in satellites than there were 6 or 7 years ago. We used to go to an event called Mobile World Congress in Barcelona, which is the coming together of all of the largest MNOs in the world. And 6 or 7 years ago, it was difficult to get a meeting with a senior executive at a mobile network operator. Oh, you're the satellite guys over there in the corner. Those are my technical staff. You can talk to them. Now all the CEOs want to meet everybody from satellite companies. Now there's an individual who is probably fairly well known, who runs a large satellite company, and he's helped stimulate that demand. It's about all of us collectively, whether it's Omar's solution, stuff that Damien and his team's working on, Mohammad or Issa's helping to support. It's on us to take advantage of that interest and make sure that our solutions are not something that are from 10 years ago with a very large antenna that's tremendously expensive and pricing that is perhaps only suitable for a tiny subsegment of a small niche market. It's about us evolving and becoming much more mass market. And we're trying to do that. And I think in some areas we're being very effective. But the pace of change is really incredible, faster than I've ever seen in the satellite industry. And so, you know, operators, equipment manufacturers, service providers, applications developers, everybody is trying to move as fast as they can, both to develop new applications, but also to gain scale, because scale for all of us is fundamental. And I think something in Europe that many companies would probably benefit from is really thinking about how they can scale up as quickly as possible, because otherwise the very large disruptive players will take so much of the market that it's going to be hard to then retake some of those. That's the commercial perspective anyway.
No, I'm just going to ask, Marc, were you asking, is LEO the answer to all the problems? I didn't get your question. Is that what you're asking?
So the question was, now with LEO, with solutions in LEO coming and offering or answering a certain number of these challenges or obstacles that you mentioned, they seem to be sort of easier solution to it. So how do you see that? Because we don't have today a competitor to the well-known US initiative, and Rhys just said that China is coming with solutions as well. So how should Europe position itself? How are our legacy players, what do they do today to offer solutions that will encounter the expectations of the applications, not only automotive, but maybe also the others?
So, I mean, I think we need to maybe separate sort of direct-to-device types of applications from broadband types of applications, because they may have different sort of responses. From the broadband perspective, we do certainly believe in a multi-orbit. And we've approached the multi-orbit in terms of even partnering in certain applications with LEO players, where it makes sense for different segments. So for example, for the government segment, resiliency is important, and therefore a multi-orbit solution is important. So having just basically one orbit response will not meet the needs of those customers. When it comes to direct-to-device, you know, that's something that we're currently looking at SES in terms of, you know, what our position is with regard to that. Of course, for direct-to-device, you want to be as close as possible to the device. So we'll see the evolution of direct-to-device. You know, LEO could definitely be a solution. High-altitude platforms could be a solution for direct-to-device, more on a regional basis. We don't have a position at this stage. We're evaluating this maybe at some point when we have a response. But for direct-to-device, I think, you know, those are good options to bring to the terrestrial to meet the requirements.
On my side, maybe just to complement what Mohammad was saying, regarding this three-dimensional, looking at multiple solutions, maybe not just one, it starts actually from very VLEO, going all the way up to the GEO or HEO, depending on the kind of applications or the user needs, things may adapt. Of course, if you're focusing on one that has the highest growth and more attention being given to it, of course, D2D, direct-to-device, is the one that is taking a lot of momentum. We see that also at ESA. There are some initiatives on our side to support that. And we see also, again, the question of aligning the technologies that are coming, maybe a near-term, longer-term solutions, that some of it is more than just the law of physics. Those understood, but then now creating a connectivity and allowing a seamless solution end-to-end, plus the resiliency and security. These are aspects that cannot be ignored. The car manufacturers maybe want to see the connection, but then when it's the next step would be, what about the encryption that has to run? What about other solutions that will come on top? So there would be, I guess, a bit more holistic looking at the problem. And one thing for sure, in Europe, important is just to make sure also to not to forget the talents and the know-how that has to be put in place and to be furnished. This is something that we have to really pay attention. I mean, we see it also collecting or acquiring these kind of talents is not that easy, and maintaining them is also not easy either. So this continuity and creating this ecosystem, whether it's a satellite or non-satellite, there would be now a convergence that we see it happening, and it's important to pay attention to it. It's not just one solution that would be only for tomorrow or the day after. We have to look at it a bit longer term.
I think the last point I want to add here is that indeed, for direct-to-device, you need to be close to the device. Even like we're talking VLEO and Ultra LEO, really coming down close so that you can capitalize on low-cost infrastructure. You know, launching a GEO and putting the infrastructure is completely different from LEO. Easier access, easier coordination. But I think if we talk about the geopolitical changes taking place, Europe has to have also its own constellation, its own satellites. If you look at LEO, you should look also at something we forget is the resilience part of it. We've seen examples of GEO satellites having issues or failing, and then suddenly you have service shut down over a huge area. With LEO constellation of thousands of satellites, that's impossible to happen. So the resilience fact, and you can easily replace quickly satellites in a very short time. So, you know, there's also other dimensions to the argument why it's LEO, and why, like, you know, the Starlinks and the others are going LEO. There might be an answer behind that.
Damien, you wanted to add something?
Yeah, I see two things that we need to do in Europe. First of all, there is a program called IRIS², where, you know, more than 12 billion euro will be put into providing a sovereign constellations. We need to make sure that that constellation could also be used for applications like the car industry. We want, for sure, our autonomous cars to be driven safely, you know, and IRIS² certainly can help. That's number one. Number two is for talents, and I join your point there. Mm-hmm. For those of you here in the audience today that are not space engineers, and obviously for the space engineers as well, but for those of you that are not space engineers, welcome. Indeed, because we need people that are outside of the space bubble, which is a wonderful bubble, and, you know, guilty as charged, we've been part of it. But for the space sector to rejuvenate and to blossom, we need to open up. We need to open up to new verticals, like the automotive sector, but also to new disciplines, data scientists, media. We need to make sure that we can bring the best talents in Europe when it comes to the future of the space sector. And compared to the US, where right now you can be a space scientist as well as a politician, it's good that we stick to the market principle. Let's make sure that we open up new verticals for the space sector.
So thank you very much to all of you. I think we have spent the time that was dedicated to our session. I hope that this gave you a little bit the sense of the opportunities that are there, but also the challenges that remain to be tackled. So thank you very much, and please applause our panel.
So, gentlemen, thank you all once again on the future of global connectivity in space and on Earth, moderated by Marc. Gentlemen, continued success, stay healthy, and have fun with the rest of the conference. All right, we'll take time for a quick selfie. That's okay. That's okay.